Good morning, ladies and gentlemen. Welcome back in room 8. We kick off day 2 with a Microsoft presentation, Performance in Business Central. And your presenters are Jesper, Bardur, Torben and Kim.
Thank you. Can you? Yeah, yes you can. I can hear myself. So, quick introduction. I'm Bardur, and I'm an application developer, architect on the base app. So I basically do the same as you guys, just on the base app. And if I miss some platform features, I can ask some of these guys. Right?
Yeah. My name is Jesper. I work on the server runtime part. Together with Torben, and I've been doing that for the last 9 years.
Yeah, my name is Kim. I'm in the platform team, mainly on availability, scaling, performance in SaaS, so on. Also security, licenses, entitlements, and so on. Been in Microsoft for 20 years, so if any questions, come to me on that.
And my name is Torben Meyhoff. I'm in the server runtime and platform architect as well. I was part of, with Kim, building the first pieces from the NST back in 2005 when we started. I was out for some years. I'm back again. I've been here for a year now and work on security, everything on the server. Been part of, been doing reporting and many other things over the years.
Great. Let's get started. I won't spend too much time on the agenda, but we're quickly looking at the overall picture, how we can measure stuff or observe, how we search and filter and such, and then locking, which is a big topic, and then 20 tips and tricks in 20 minutes. I think it's actually 21, but it sounds better. Yesterday there were 2 very good sessions on performance, AL and indexing, and today, after the session, there are another 2. So this is just some advertisement for them as well. And we believe that there is not much overlap between any of these, including ours. So this is a high level and technically wrong, but a high level picture of the environment. Our users sit on one end with their browser, and then we have the cloud, but technically it's 2 different machines. We have the web server and NST on one machine, or actually many machines, but together on one machine, and SQL Server on a separate machine. Now that means that there's latency between these. So from the browser or from your users to Azure, there is, 50-ish milliseconds. And between the NST machine and the SQL is 1 millisecond-ish. And the important thing is that there's executing code on all of these, right? SQL, of course, SQL statements on the NST, AL, C# and .NET stuff. But also in the browser, there's executed JavaScript and HTML interpretation and so on. So when a user does something, we in Telemetry, we can see where is time spent. And if I quickly, these numbers are not very important, just the guidelines. So these are some page opening times. You see customer ledger entries, chart of accounts. So these are some of the slow pages. And you see that these take maybe 2-3 seconds to open. But actually, approximately half of the time is spent in the browser, not on the NST, right? So, and I and you guys, we can only influence this duration in NST, which is the sum of AL execution and SQL execution. the lower part there is, we can also see page interactions. You know, user clicks something and moves a field or validates. And the interesting thing there is that when they navigate, most of the time is actually spent in the browser. You can see, if you look at the duration of the NST and down, meaning you can see that it's not much, and this is what usually I and you can do something about in AL code. That piece of information is not really important, except that this is what we consider okay-ish usability. So when somebody tries to open a page, we say 2-3 seconds, that's okay-ish. Same if you are on a page and you move from one field to the next, we say, you know, half a second for a validation is okay. And then I know that we have sales line quantity that may be a bit longer. And of course, if you type something, it should be immediate. Then Kim will say something about measurements.
So let me just spend 20 seconds on what we're not going to talk about in this session. In SAS, performance, availability, the compute, the database performance, all of that is on us. We make sure that you have all the resources you need. If you feel otherwise, come talk to me in the export corner or after the session. So what can you actually influence and verify when you have your customers complaining about performance or raising a question, issue, something like that? The reason why we bring this up is that from the telemetry that Bardur just, or the information here that Bardur just mentioned, is that sometimes we can see that it's simply, we see this because we emit telemetry from the browser, and that we evaluate and understand and so on, and it gives us a picture that the browser is sometimes too slow to actually handle the UI. And this is either it's a complex page or it's a bad connection and so on. So this is for you to verify, right? This is not a recommendation, it's a suggestion. Use a tool to see what the speed of the PC or the tablet, device, whatever the customer is using. And then you can see it's actually shifting in performance. It could be just after a few minutes, it's bad performance or good performance. So this could actually be the reason why the user is having a bad experience.
So just to interrupt, I measured these two, and in one of them I was in a meeting, the laptop was on battery, then I came back and plugged it in, and then it was suddenly 25.
Yeah.
Just saying there, even on the same machine, it can be different, right?
It could also be in a warehouse, your user is using a tablet. Walking around the warehouse, bad Wi-Fi could also cause this. So not the speed of the actual browser or the tablet, but the connection could also be the root cause. So measure your speed, measure your ping time. What is the latency of your device? One thing is to do in your office, do it also at the customer place. If customers multiple different offices, then it's also important to say, okay, where exactly did this happen? And it's not always the back end. It could easily be the front end that is having an issue. Related to SaaS, of course, you need also to verify your connectivity to Azure. There's plenty of speed tests you can run, and then verify what the latency is to your region. And again, do it on the customer location also. So if there is a connectivity issue, you can always use the connectivity/connectivity or the acronym here for any of the environments. Just put connectivity afterwards, and then you will see this page. Now, this is mainly about connectivity, but I know our client team is also using it for, or planning to use it for measurements. So imagine we could add a little script to see the download speed, the compute of actually doing some calculations, and that could be fit in here. Then we get the information, and we can perhaps provide you the feedback later on. So use these tools and then verify that your client is set up for success.
Yeah. And then we come to AL, which I and you write. And if you've seen any previous presentation, I may have mentioned this before. So when we execute AL statements, just not database statements, but just assignments and calculations and stuff, we can execute approximately 1 million lines per second. Maybe it's not 1 million, maybe it's 700, maybe it's 1.3, I don't know. But that kind of ballpark. SQL calls usually take at least a millisecond due to the latency between the NST and SQL. And then, of course, if it's a very complex SQL statement, it will take longer. I once looked at all our code units, counted the database statements and the non-database statements, and divided. So roughly we have 10 statements, non-database statements for each database statement. And if you think of your own code, it's typically something about set filter, set range, and then some calculations, and then we find a record and do some other stuff. But all that, if you calculate or multiply those values, you can see that we actually spend, maybe it's not exactly 99, but 90-something% of the time just waiting for a database statement to finish. And when I said 1 millisecond latency, it's obviously not exactly a millisecond. It has a distribution, so it ranges from something that's very fast, like half, and up to, 2 out here. But the weight is like somewhere just under 1. And does this matter? Yeah, it does. Because we also looked at when people run code unit 80, we can see how many SQL statements they're executing. And of course, I don't know if it's just invoicing or just shipping or shipping and invoicing, but half of them spend approximately 1,000 SQL statements or more. So that's a whole second, right? 1,000 milliseconds is a second. And the 5% of our customers or our postings spend 38 seconds just on waiting, right? Just to set the stage we're working with. All of these things affect performance, that. Latency, locking, number of records, indexes, memory, CPU, blah. We have telemetry, and I guess many of you use telemetry, and if you don't, you should. Applications insights, as it's for you. That screenshot is some of the runtime events that are emitted. When I look at telemetry, I mostly look at long-running queries and long-running functions, because sometimes one function can have many small, short SQL statements, like loops and such. And you also have user errors, by the way. If the type of wrong date or something. We don't emit everything we get to you because it's expensive. You pay money for it, or your customers do. And we, just before this event, we actually counted, just for fun, how many telemetry entries do we get in an hour, and that was a lot of billions, and corresponds to over 1 million per second. That we get from our total base of customers. So we also spent an enormous amount of money on telemetry. I think Jesper told me that in the beginning, until we got it under control, it was one of our biggest expenses. But then if you have telemetry, then you can build Power BI reports and such on top. This is just an example of one of them. I won't go into details, but when you have it, you get interesting stuff like which code unit is it? I think this is a demo from somewhere. And when I look at long-running queries, I usually summarize because there's always one slow occurrence and some fast. So it's more interesting to summarize. And these are some examples where we summarize for pages. I won't delve too much into the numbers, but just to say that this is the kind of numbers we can get. Another way to do it is we often get a complaint from some customers saying, when I do blah, it's very slow, and then we say, can you give us a profile, and then they don't know how to do it. So I don't know if you use it, but I'll quickly show how to do it. And the great thing there is that there are two ways to do it. So I will go over here and refresh. So under help and support, can you read it? Yes, you can. Down there is something called Analyze Performance. And then you can click Start. And then you go over here and do whatever you want, like, I don't know, creating a new sales order. There. 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 I mean, this is enough. Stop. And then we get this more or less useless picture. And then we can click there and get a bit more, and you could get a bit more down there under call tree. But the real gem is this, the download. So when you download something, we get, sensitive data, yeah, that's fine. And then it's downloaded, and then you can look at it. And I already opened one of those similar files. Actually, I can take one. This demo. This is way more complicated than what I did. But sometimes the customers have really complicated scenarios. So this is from some batch job, some production planning or whatever this is. And you can see that this took 500 seconds on the item after get record. And then you can drill down to see where time is spent. But what you also can do, there and there. And again, if you don't know this, there are two times here. There's the time that is totally spent in the scope of this function, and then it has a self time, right? So in this case, the code function spends time 10 seconds itself, and then other functions that are called spend the rest. And then you can dig down and try to track what takes long. But if you're lazy, then you can actually go to the leave and summarize the leaves by just clicking this icon over there. You can see, which is sorted by self time, and then you can see where time is spent. So apparently something that's called calculate route line is the most expensive. And then you can, if you have the project open in the Visual Studio code, you can double click here, and it will get you into that function. So you can analyze more here and see why is this slow. That was one way to do it. The other thing we have done is here, because I have some pre-baked over here. Analyze performance with schedule profiler. I don't know if you can see it, if I duck my head. So here you can have several scheduled profiles, and just for fun, let's make a new one. BC TechDays 2025. So in here, you can say, I want to observe this period, and let's say that you want to analyze some batch job that run at night, then you would put a time in here that is at night. And you can specify a username if you only want a specific user. It could also be you just want everything. And then the smart thing here is that you can select what do I want to track, because the browser thing might be easy, but we have background tasks, meaning job queues basically, but also web service calls. So that's great. The way the profiler works is that there's a timer that, every, as it says there, 100 milliseconds looks down and say, where are we now? And then 100 milliseconds later, where are we now? So over time, it will get a pattern of where are we most of the time. You can change that resolution to something else. And you can also say, I don't care about jobs that take less than 500 milliseconds, for instance. And then in here, you will have the logs being exactly the same as we downloaded before, which is also why I pre-baked one. Can't remember if it's this one. Profiles. That was not it. Sorry. Then it was this one with the profiles. Right. So I think I ran a report like customer top 10 or something. So you can download these and then look at them. So this is a great tool when your customers complain about something very specific. These slides are just to show what I just showed. The only interesting thing sometimes there's also a point called idle time there. So this could be anything. This can be the user, reading the screen or drinking coffee or waiting for the phone to call or whatever. But in this case, when it's printing a report, it's the NST that is waiting for the RDLC renderer to, render this report. That's also idle time seen from EAL standpoint. Then we come into locking, because I watched one of the good sessions yesterday, and they didn't touch much upon locking, so we thought it was a very good topic. So imagine you and your friend, wife, spouse, whatever, go to a burger joint, and the process is you go over there to the counter, you order your meal, you wait, you take your meals and go to a free table, eat, go out, right? Now, sometimes it looks like this, right? There are a lot of people, and you do the same, right? You go to order your meals, wait, and so on. Except my wife. She would go and immediately occupy a free table, if there is one, because there's obviously shortage of free tables. And then we queue up and wait, and nobody uses half of the tables because people are waiting there for no good reason. I guess you wouldn't do that. You wouldn't, right? But in our world, that corresponds to this GL entry.log table and find last we have like sprinkled everywhere where we want to have the world for ourselves. And once you get your food and you get a table, it's old, right? Or in our language, we can't save your changes right now because something is locked. So we should always lock especially limited resources, as late as possible. Think of a printer, right? If you are printing a big report, I mean, let's say that it takes time to generate a report, you wouldn't go and lock the physical printer before you are ready to actually print, right? Then we also have the fun of the deadlocks, as you know, which means that we need to lock in the same order, which also gets a bit back to the McDonald's example. So what we, for instance, do for GL is that we try to post GL towards the end of process. So we lock GL as late as possible. But sometimes we do it early because we are, doing different stuff in different orders. So that leads me to a short intro on locking, and you will, I know many of you know most of this, but I'll still go through some of the basic scenarios. So in the UI, we rely on optimistic concurrency. So if you read the code there, it's the same code both blocks. So we read a customer, change the name, and then we wait, just to let the other start. And then we modify the customer, and then we are done here, right? So the other guy who opened the customer card after will get this error saying another user modified this record. Or, as our good UX people think, this is a more kind message. Sorry, we just updated this page. But it just means that somebody else has updated your record. So that's one scenario where the one we call optimistic concurrency. Then we have the other we can call safe concurrency. Again, it's the same code in both, except that this time we put an update lock on the customer, and the user 1 gets to this spot, and user 2, because user 1 goes for coffee or something, right? And it's working on it, and eventually a timeout. Right? And then, but user 1 is happy with his coffee. Then we have read isolation, and it's something you really should start using. We have slowly, if you look at our code, you can see we more and more sprinkle these read isolations out. So if you look at this one, first we update the name to hello, and then we modify it and commit. So now the database says hello in the name too. And then we do the same again where we write world and modify, but then we pause here, right? So when we get to that here, we have modified the customer, but it's not committed to the database. So on that one, right, we'll see, so we read uncommitted, and what do we expect that to show? World, right? Because that is the uncommitted thing we just written to the database, but it's not committed. Then we can use read committed. And as you will expect, it will give you hello, because that's the one we committed. But there's a catch here. That's only if you have set snapshot isolation level on for your database, which I believe we have in our environments. But otherwise, you'll actually get a timeout, because the read committed actually locks. The platform tells me, oh, but it's only for short time. Yeah, but if the record is locked, I can't get it. So just a warning, read committed may be just as bad as update lock in many scenarios. Unless you set on snapshot isolation, which is some tricky command you can issue on the SQL server. Then you might remember that as soon as you insert something, so now we create a new customer with some GUID as a number, so we know it's unique. We insert it, and as you may remember, sometimes when you insert, we immediately get this lock table thing on the customer. And then we call this function where we say get number of customers with the same name, which is canon, and anyone who knows the demo data would know that canon is one of the demo data customers. So this one, set filter and count, the count would actually lock all the canon, all those records. But we don't. And that's actually the new improvements we made for maybe it was 25, maybe, or 25 I think was the tri-state locking, and also the calc sums and count and so on are not locking. So that's a good thing. Then we come into updating several records, 2 processes, and in this case, both of these do exactly the same, just in different orders. Here it's a customer and a vendor, but could also just have been 2 different customers. So, right, so up here we update customer 1, the customer, and then we wait, and then up here we update the vendor and then wait, and then do the opposite. So we get there, and then we make sure that the other one gets there. So what do we expect on number 2? Yeah. We get a lock timeout. And I guess somebody in this audience would expect a deadlock, right? So why didn't you get a deadlock? And the thing is, we did get a deadlock. If you look in telemetry or the event viewer, if you're doing it locally, you can see that we actually did get a deadlock with this ugly thing. But we can also see that there's another telemetry event that tells us that the server was kind and detected this and just retried the operation. So these guys are actually saving us from some of our mistakes. The last thing regarding locking is we can also get locks from SIFT, and I guess most of you know that. But just know that you should use SIFTs carefully, because they're expensive to update, but they also make retrieval of sums, that's all very fast. And so a few versions ago, we had this key on our purchase line. And by the way, all our sales and purchase lines indexes are now only using included fields, so we removed SIFTs from them to avoid locks. But we had this index on the purchase line, and I don't know if anyone can say something was wrong about it. Anyone? No? It looks innocent, but on average, what's the job number on a purchase line? It's blank, right? And job task number, blank or 0, whatever type it is. So basically this meant that for each document type, quote or invoice or order, it was a single user system. Only one user could, basically we had a table lock there. So if anyone was posting a purchase order, people couldn't edit. That was not good. So, as you might know, we started a journey in 25 and continued in 26 and will continue for further releases to try to make things a bit more concurrent. In 25 we did with warehouse entries. In 26 with inventory. A bit more on that later. So if we know that several people or processes are adding to the same table at the same time, maybe even on the same item, in this case, right? So we need some way to distinguish the SIFTs. So you'll see that on some of them we have added this SIFT bucket number, which is just, it could be anything, it could be a random number, but we chose to say that it's warehouse register number modulus 5. So it'll always be 0, 1, 3, 2, 3, and 4. And then we'll come back to, I'll start on the locking. So traditionally, whenever we have entry tables like up there, VAT entry, GL entry, check ledger, whatever, we do a lock table and find last, right? But that means, as you know, that only one person can post to whatever system at the time. And as much as we want our code to be fast, the total throughput is also important. So, I mean, if you've seen our launch event videos, this is basically the same. But just to repeat, so the way, and I wrote, did it work? It still works like that if you haven't turned on concurrent posting. So some ledger entry, post whatever, there's usually some init function or beginning of a procedure where we do a lock table, find last, we save the entry number, which is a global variable, and that's it, right? And then at some point later, we want to insert some ledgers where we increment the entry number counter and assign it to the entry number and do stuff and insert, right? So, yeah, and this means that only one session can do it at the time. So the way the change we did was that in the init function, I mean, if you have turned it on, we don't do anything. But when we post, we assign a number for the from the number sequence. Most of the functions, or most of the tables have got this get next entry number function on them, and which will go and take from number sequence, which is, think of it as these number dispensers at your bakery or wherever you have these. And there are several reasons why we chose this. One of them was that we could leave the code pretty much unchanged, and all your events would still work most of the time. So, and as I hinted, it's only if you have turned the concurrency on that we don't do this, right? So what does that do to the item register, where we have this from entry number and to entry number, and we have the from value entry and so on. So there's these 4 tables that are connected to the item register. As you can clearly see in those yellow boxes, there are huge overlap, right? You can see that these processes were started almost simultaneously. So the way the drill down works now is that We still put that range on, as you can see there, but we also put a filter on the item register number, which we have added to the entry tables. Since we don't want to upgrade all the, some people have hundreds of millions of entries that would take days to update, right? So we just left the zeros out there, meaning that if it's a 0, it means it's an old style entry, and then the range is correct, right? And if it's a new style, then the item register is correct, then it's not 0, it'll be 102 in this case, and then that will add an extra filtering. And then we have this ugly stepchild. It's called inventory, automatic cost posting. So this is an item journal I'm showing a picture of, but it's the same for a sales order, for instance. Just think of the lines in a sales order. So for each line, we go and post to inventory. And if you have turned on automatic cost posting, we call out to GL, and then we know it's game over, because then GL is locked and we can't make any concurrent stuff. So what we did to solve this, or amend this, is that we collect all the GL entries, or the processing, and we save it to last. So we process the GL entries just before we process the other GL entries we otherwise would. Again, this is about locking the critical resources to as late as possible. And does it matter? So this is a screenshot done on, it's in SAS. It's not a prod tenant, but it's a prod-like tenant. Each of these two windows have 500 item journal lines, different items, because if you post to the same item, you get into this remaining quantity and all this. But it does have automatic cost posting on, and if I ran one batch alone, I didn't repeat it that many times, but if I ran it alone, it took 19 seconds, but ish. And if I ran both at the same time, the last of them, because they don't finish at the same time, obviously, ended after 23 seconds. And again, this is unscientific, a few experiments. But you can see that it clearly gives you a better throughput. And I think even more important, the second user didn't have to wait for 19 seconds before something happens, right? I think that's probably the most frustrating for people, that they have to wait, nothing happens, working on it, you will see. Basically the same for sales invoices. I made this test specifically because we also have customers who run subscriptions, and some of them, those customers use items, service items, as subscriptions. And the good thing about that is that they don't update the inventory, meaning we don't need to go and update the item, incoming item ledger entry. So I created a lot of sales invoices, ran batch job report 297 in job queue entry. And if you did one of them, it took approximately 15 minutes. 5 of them took approximately 17.5 minutes, which gives us a factor 4. And it seems like it's saturated there. I mean, I also tried with 2 and 3 and 4, but it seems to saturate around 5. I also tried with 10, but it gave approximately the same. So one last note on this specific topic on sales orders is that you remember the talk about deadlocks. So if you have two orders and one updates item 1 and 2 and the other order updates item 2 and 1, you'll get a deadlock. So in the next version we are releasing, we will actually sort the lines by type and number, meaning yes, we may get locks, but it will be not deadlocks, right? Locks are better than deadlocks. And then a short thing about how do we test this? So obviously, telemetry, I mean, we can just observe what is going on out there. So we have a lot of live experiments, so to speak, in telemetry. But if you sit and if you develop and you want to make sure that your stuff works concurrently, you can use BCPT. We have several presentations on this, so I won't go into much detail. But in this case, you can see I had 4 sessions, just thinking of it as coding.run, right? So each of these are just coding.run in the background, and they post, some post same items, some different items. And then you can let it run for a minute, 2 minutes, whatever you want. And then you can look at the logs. And then in the log, you might get errors like that. You can see that this activity was deadlocked with, and then you can go and look at the call stack. And call stacks, that could be something like that, for instance. It could be anything. I mean, this is just one random example where we had updated one item, and then, as you know, if you don't use the new modern read isolation settings, then you get into a table lock, so the next item you touch is also locked because it's a global variable. So what you'll see is that we sprinkle some of these read uncommitted over the code to avoid these kinds of things. But this is good for debugging, and it's pretty easy once you set it up. You run for a minute, and then you can see, did I get any deadlocks? Yes, no. Similar thing with a lock timeout, but then, of course, requires some activity. Yeah, I won't get into details, you know about this. So, and don't read the code there, it doesn't matter. But the point is, use these different read isolation for different purposes. So in this case, we iterate through with where we don't want locks because we don't want to lock other people, right? Only for those we actually want to update, we want to lock. So, yeah, I think that leads me to Kim.
Yep. That's right. So, telemetry. It's simple to use, it's critical, it can give you really good insight into your business, your code, what it's doing. We are halfway into the session. I think it's about time to raise a hand who is using telemetry, and I expect everybody to raise their hand because everybody should do it. And please keep it up. Who is using your own telemetry in your own statements in telemetry? Okay, who's using Verbose telemetry? Okay, cool. So many of you know telemetry. I will go through the setup. It's really easy. I will go quickly through it. Sometimes it's enabled by somebody else. You don't really know how to do it. Use it for your customers. Use it for your own test environments. You have your own reports, your own app inside storage that you can use and test your own stuff, and then have a look at what your code is actually doing. You can use it for customers, or you can use it for your extensions. First of all, you need an app inside storage. Once you created that, it's really simple. Just follow the guide in Azure portal, copy the connection string in the tag, insert it into the telemetry point here, and then you're basically done. So, and also, please don't share the key. If you put it in your extension, don't, and your open source, or you share your code, then by mistake somebody could actually use your connection string, and then you get somebody else's telemetry also in your storage, and you don't want that. So here's a few tips how to set it up. The first link is just a general help, how to use it, how to set it up and all that. The second one brings you to this page. And this is the app that you need for Power BI to show the report of your app insights telemetry. It's simple to set up. Just follow the guide. Once you have it installed, it shows a lot of demo data. Have a look at that first. See what report you actually have out of the box. Then click this link and then authenticate with your own App Insights resource, and then you're actually running. This is just a new customer, new environment, and I enabled it for that one. So if you do it for telemetry, for your extensions, you put it in the App Insights connection string in your extension, and then it logs all of the usage of your extension to this connection string here. So, and then a bit of, it's a tip for me. Normally people use the Data Explorer. I personally use the Custo Explorer. I'm not sure if you're familiar with it. It's a Windows application. You download from the link here. I will say it's one of my favorite tools. And also F5 actually runs the query, doesn't refresh the browser. So it's really, really good. So have a look, try it out. It also stores your queries. Once you close the browser, you open your laptop, Windows will restart your PC, you open Custo again, your query is back where you left it. So really nice. In order for you to set up Custo, you need the resource ID in your App Insights resource. You prefix it with the App Insights URL, and then inside the connection string, you just add it, and then you have access to it in your Custo. And then it looks like this. So your own telemetry, this is two statements I did here. The key is the tag. You can see I can call the KCK001 and 2. And then also the scope. You can see the first one is all, and the second one is extension publisher. That means that the all goes to both the customer and your extension telemetry. The second one only goes to the extension where the code is executed. There's also a dimensions. It's not that important in this case. Also, be mindful what you log. It could be you're actually violating privacy aspects. So do be mindful of what you actually log. And this is how it looks. If it's the extension that you see, you can see there's the all and there's the extension publisher, right? And if I do the same for the customer storage, they only see the all event. So then the verbose part, you can do that your own. You can create your own system and then put it just use normal. But you can also use the verbose tag. And then on the page that Bardur showed earlier, you can use this and enable additional logging. Then for that session, from now on, it will log verbose statements also. So if you look at how that would look, you can see here I have the customer, and it gets 2 of the normal event to all, and then in the same session I enabled verbose, and now I can see the verbose statements. When you create a new tab, it's a new session, and then the verbose is no longer active. So it's only for the reminder part of that. So you could also say if you have a repro, your customer has a repro of an issue, and you have verbose statements, then ask them to repro it again after they enable it, additional logging, and then you can see a lot more details depending on all your log statements. So please go ahead and do that.
Yeah, that's one way to save money on telemetry is to make sure you only log the important stuff always, and then log the the stuff you need for specific investigations as verbose, and then you can enable it. Then you don't have to pay for all of the stuff all the time. Yes, and I will talk a little bit about some new features that are helpful for improving performance. For 25, we shipped Optimized for Text Search, which is our name for the SQL full text feature. It's something we have opted in for a number of tables in the base app, mainly master data tables. You can also opt in on your own table extensions, on your own full tables, and you opt in per field, and it's not like a normal index where there's a specific order. You just apply it to the field directly, and then you can use the index in any order and any combination of fields. So when you have an Optimized for Text Search field, previously you would, from the search from the client, it would just turn into a SQLite statement with some wildcards, and that would force SQL to go through all the data to see what matches. The moment you enable Optimized for Text Search and then query from the client, we will automatically turn that into a full text contained statement. And what that does is it builds up a list of words instead in your data, and then searches the word list first, and then cross-references that with what words showed up in what lines, and then you will be able to more quickly navigate to specific lines in the data without having to scan through, for example, 200,000 items or however many rows it is you have in your data set. You can instead go directly to the correct rows based on what rows contain what words. One small downside to that is that because it's a word index, it can only find words that start with a certain thing. So if you have chair and hair, you will not be able to find hair based on chair because it does not start with the same letters. So that's a downside. It's not free. It's not just better. It also has some downside. But it's a compromise. And for most cases, when you just type in the item number or whatever thing you're searching for, then it'll be much faster. And then if you have a specific scenario where you need to search for something that ends with something, you will need to either use wildcards or switch back to the previous way of searching. In the web client, it looks like this. So if you have a table where where you have opted into Optimized for Text Search, you will get the small arrow, and you can select Modern Search instead. And that will then have the new behavior, the faster behavior. You can also switch to Modern Search and use your own wildcards, like put asterisks in front and in the back or in the middle. If you do that, then we will automatically figure out, okay, can this be done with full text search or not? If it cannot, then we will convert it to the old style. Of course, the performance will go back to the old performance as well, but it means that you don't necessarily need to switch back and forth between the two to have the fast behavior and the slow behavior. You can just add wildcards yourself, and then you will see, okay, can it be handled with one way or the other, and then we'll try to do the best way automatically. So then you don't need to switch all the time. If you have a scenario yourself that is, you want to do the same thing what you see in the client from your code, you can do something like I put in the code there, like filter group -1, and then you set up these filters the same as we do them. It's a slightly convoluted syntax with the double ampersands, but the reason it is because we have to pick something that isn't in use already, because we don't want to break existing logic. So we found something that we can guarantee is not already would not break existing logic. So that's the syntax we went for. Yes. So performance. So this is just, I picked one example from production, had to find something to see how was it going after we rolled this out. So I found one that had previously, before on 24, used wildcard search a lot. So they, for a normal Tuesday, they had 5,000 queries that took longer than 750 milliseconds. So that was not great for them. So then we upgraded them to 25, and we could see that the next Tuesday after the upgrade, they were at factor 10 less of the previous style queries, legacy queries. That was either tables that were not converted to Optimized for Text Search, or people that manually went back to the old style search, and then 5 slow modern search queries. So the 4,500 queries no longer showed up in telemetry. Of course, I cannot say we only log queries that go beyond a certain threshold. The ones that are below, they don't show up. So But we can at least see that a lot of queries were much faster after this. Of course, it's not all great. I already mentioned the part with the starts with versus contains, the other thing is that you have in full text, it's a normal challenge it's not a specific challenge to full text search. It's in general that every time SQL has to evaluate a query, it has to decide which part of the filter is the one that is the most relevant to do first to cut down the amount of data to look at. But it's especially important with full text search because if you choose to not use the full text index, you are back to the same performance you had with the wildcards, actually sometimes even worse. And what we see in some cases is that some queries decide, the full text search is not optimal here. For example, if you search for a single letter, the query optimizer has a tendency to say, probably no reason to use the full text index here because it's going to give you too many records. So I'll just use the other part of the filter. For example, in this case, if I have an item that is where the description is chair and it's not blocked. If you have that case, then if you are not lucky and SQL decides to pick that, I'll start by getting all the ones that are not blocked and then apply the full text filter, then you're actually slower than you were before. Some of this we have been able to mitigate ourselves because some of it is heuristics in SQL side. So if you do find first and a full text query, they think, there's no reason to use the full text search here. So good thing is, if you need full text querying, then it's good reason to use get all the data or get the first 50 rows because then that pokes SQL in the right direction and says you need more data. Okay, I should probably use the index. But some of this is experimentation and figuring out how does the query optimizer look at the query and decide what to do. This is at least one of the tricks we found. Another thing is that there's some overhead. Like you probably don't see this, but adding more full text search indexes, especially when you have many companies, like 300 companies, 50-ish full text indexes, I think we have in the base app today. You also add it for table extensions, then you have 30,000 full text indexes. Once everything is running, not so big a deal, but we have seen at least cases where when you have to stop and start the SQL server for scaling purposes, convert from one tier to another, it needs to do manual processing on each of those full text indexes, and that takes time. So there's if you don't have enough data to get benefit out of full text, there's no reason to add it. Like keep using the wildcard statements. It works well enough for small tables. Then another feature that we recently added in 26, it's currently opt-in, so you need to opt into it, is to calculate only the visible flow fields. Before any flow field, even if you had specified manually visible false, I'll never see this, we still calculate it. So we fixed that, currently opt-in, so you can only calculate the visible ones. There's a small detail is that you have some fields. If you put a field in a group in a page, you can flip back and forth between whether it's visible or not, depending on the data. And in that case, we always calculate it because we cannot halfway during the page load decide, now it's visible. Now I have to go back and calculate the values. So it's only stuff where you can detect as soon as the page is open, this field will stay visible or stay invisible. Then we either calculate it or not. If it changes during, after the page is opened, then we'll be unfortunately forced to calculate it still. But the most fields either stay visible or stay invisible. There's not that many that go back and forth because it's also jarring when you look at the UI to see fields that pop in and out. So it doesn't happen that often. This is an example that just like what I mentioned with if it's false, if it's true, it's easy. If it's decided out when you open the page, it's also easy. But in the case where it's part of a group, you can see here that the one at the bottom, the visible group, there we need to always calculate it. Then a small sneak peek on what we're doing in 27. This was almost done for 26, but didn't make it. But if you look at something like chart of accounts and other pages, you will see that there are many calculated flow fields, and a lot of them look very, very similar. And that's also what I saw when I looked at this. And why are these so similar? Because I don't do much application code. And they are very similar. And what we found out is that why not just combine all of these? So in this case, you can see here it's is the credit debit fields on customer ledger entries. Like there's the only difference in these, they have exactly the same filters, they're exactly the same source table. The only difference is what field are they aggregating. So what we're doing for 27 is that everything that has exactly the same filters and exactly the same source table, we're grouping it. Of course, there's some operators that can be grouped and some that cannot. So exists and lookups, if you are doing lookups and exists from the same table, we can group those. If we're doing sum, average, and count, we can group those. If we're doing min, max, we can group those. And if you look at the query plan here to the right, you can see the top one where we had the four different flow fields from exactly the same table. They were doing 4 joins and 4 subqueries to calculate each of those. And if you look at the bottom query plan with the estimated cost of like 70% less, it's a single out apply, single join to calculate all of those 4 aggregated values. Yes.
Yes, over to sound, I guess. Yes, sound is on. 20 tips in 20 minutes. There's a lot of things that over the past has people learned how to do the things, but we think there's something we really want to reiterate also. So let me start with the first tip. And Bardur actually mentioned part of it before. When we run AL code, we actually run a compiler on top of it, and we emit some C#, we compile C#. But to actually to do all the nice things you see on telemetry, to enable debugging for you guys, we emit code around every statement. So if you have something that is heavily using AL statements, it could be something low-level JSON calculations +1 and all these kind of things, really consider when you want to have really small methods, because inlining doesn't happen, because we have try catches in our code, we have using lambdas and other kind of things, so we will never inline things like that. So if you are coming to a point where you have really small things, consider sometimes do duplicates, add them directly to your function calls, because there is an overhead. We're only in the microseconds range, but you can performance tune the very low level stuff here. And when you do parameterization on functions as well also, the AL language will copy you unless you are by var. So if you have complex types that you put into a function call, like a record, do by var if you know there's no risk of people will hurt you on the inside if you're the only consumer of it, because then you don't get copies of objects. There's always, when you are heavy on these levels, we have a lot of the wait times that Bardur talked about. But this is where you actually hurt memory on the machine. So if you produce a lot of things, then you put things to the top of the garbage collector. So do inline your own code, because we don't inline it for you, because we always have to add the overhead calls. This is one of the ones that we added to query, save as JSON. It has the save as CSV and has the save as XML already. If you handle a lot of JSON, you often pile up a lot of things. You make big pieces of memory. This one is stream aware, and it means that it will take your, make your schema as you know it already on any other query, and then you can, in a streamable fashion, actually create big documents without putting pressure on the machines. So performance-wise, you will get it much faster out and much less pressure on the machine.
Yes, and then Bardur also mentioned this, that it's not free to call out to SQL. So what you can do is do whatever you can to reduce SQL round trips. And one of the things is that I just mentioned about autocalc fields. If you do autocalc fields, you inline all the calculations while getting the data. So that means less trips back and forth to SQL. You can also do query objects, of course, to do the aggregation inside SQL. Meaning you only have to go to SQL a single time, and then you get all the data and all the joins and all the aggregations at the same time. So whenever you have stuff where we can see, here I'm summing in AL, think again, see, can you do this with a query object? Also, even the calc sum is also does the same thing. It offloads the calculation to SQL, and you don't have to pull out the data to the NST, look at it all, throw it away again just for the aggregation. There's only one small exception to the rule, is that the best trip to SQL is the one you don't do. So if you have something that you can see you're requesting often with a GET request, for example, those are very easy to cache for us. So GET requests almost always end up in the cache and can get reused later. So in that case, if you have something that could be done with a query or a GET request, a GET request is always preferred because that one goes to the cache and the query result does not. So then you skip the round trip completely. That's even better. Then use the right type of find. If you don't need any data, you just need to know if it's there, then isEmpty is great. You're not getting the data, you just know SQL can stop as soon as it detects that there is data, or then it can stop and say, yes, there is something, fine. You don't need to get the data, you just need to know that it's there. Find first, if you need one result, just one, then find first is great. But what we often see is that some people do find first and say, great, there's one result, and then they call next. But find first gives you one result. So the moment you call next, you need to call SQL again and say, hey, I want some more data. You don't see this, but you have to pay for it. Find minus, if you want to do find first, but 50 results instead, find minus is going to give you that. And if you want to use everything, then select is, find set is going to give you all of that. One thing to know, get versus find first. Find first with a filter on the primary key automatically gets translated into a GET request. So it's not critical whether you do one or the other. We can detect that this is you are all using all the primary key fields. We can just convert it for you. Then Bardur talked a bit about indexing. The fastest you can do, as I mentioned, is the get. Like it's primary key lookup. You know exactly where to go in the data to find that data. The seek is the next best. Is when you have a key that is tailored complete to your query. You have all the set range and the set filter fields are in the key in the right order. Then you can seek into the index, which is the second best. Index scan, still good. You can get the data from just the index to figure out what to find, even though it's not the right order. You don't have all the fields in the you don't have all the fields in the right order or in the set range. Then you can still do the query using just the index. But the moment you do a search on something that is not in the index at all, then you need to go through all the data. And that is fine if there's not that much data, you don't do the query that often, fine. But if you have something that needs to perform and you need to go through all the data, yeah, that doesn't work great. Iterating data efficiently and especially modifying data in loops. So, of course, we have some bulk operations in Business Central, but if you need to go through data and modify it in loop, or even just go through it in loop, the moment you start changing the filters, changing the SetLoadFields, changing the AutoCalc fields after you called find, then we have to restart because we didn't get the data the first time, and now you say you need more or less or different, then we need to issue the query again. You just call next, but we actually have to reissue the command. Avoid set current key on the fields you're modifying. Set current key changes the order, and if you're changing the values of that are part of the ordering, then you're actually moving the cursor around. So the moment you call next after you change the value, then you say, oh, but you are now, the value changed from 1 to 5, you want the next from value 5. So you should not sort by the stuff you're modifying. It's not great for anything. And then secondly, we try to be smart with not starting over too much. But if you copy the values around, so you have one record instance that you're iterating over, and then you copy it to another record, and then perform the modify over here. Then the link is cut between the two. So we don't know, we just see something changed. So then you also end up with more restarts than is necessary. So do the modify directly on the record you are iterating, or the delete if you're deleting. That will give you the best performance when doing loops and modifications.
Yes. All the way back to C-side, the way to collect big amounts of data was to copy from record to a temporary table and then use it for a later iteration and get your data out of it. It is a pretty heavy operation. We use a memory database behind the scenes, so everything is piled up. So if you copy 1 million records, it will all happen to be in memory on the machine, and you put a heavy burden on it. And performance-wise, it also just takes time. So we added some of the native types. So if you need, it's just key value pairs or some other structure that you would like to have saved, use the dictionaries. If it's just a matter of getting a long list, use the AL list. They are behind the scenes just ordinary .NET objects. temporary tables is just heavy, but use them when it's convenient. It has the the insert, the update, and you can search on them and so on. But they are in memory structure, and they are pretty heavy on the machines. So don't use them unless they have the purpose of being a record behavior that you want right now. We made a new feature called SetLoadFields. And that is, it's similar to the code before. The code you don't load, the calls you don't call, it's always faster than not getting the data in. So if you do SetLoadFields, you can ask for specific fields to get loaded. If you're in a scenario, just like let's say you're filling up a dictionary, you have like the key that you would like to get added, and some other values that you would like to have piled up. So instead of running some of the big tables where we have like 50, 100 or something like that columns on the tables. It's just a big waste to take the records. Records is ISAM based, so we load them in, and you next, and you next, and you next. If you only need a few fields, tell the system up front, I only need some specific fields, and then your iteration will be much faster, and the cursor in the SQL Server will be much smaller for you, and so use that all the time, and especially skip out all FlowFields if you don't need them as well, also in the same run. Here's an example from the documentation. The link to the documentation is in the bottom. You get the PDF afterwards with all the presentation. This could also have been a sum index, the sample from the sample page. But yeah.
Yes, and then this is a specific tip to upgrade, because data transfer is only available in upgrade. But we still see upgrades failing, taking hours, and then we go look at what was actually happening, and we can see it's just looping over hundreds of thousands of records, and maybe the code was written when there wasn't 100,000 records, but now there is, and it's not performing anymore. So every time you write upgrade code where you need to transfer data or modify many fields, and you don't care about the triggers running, use either CopyRows or CopyFields. It can handle both within the same table, from different tables, conversions, also if you're scaling up like from integer to big integer or some other kind of migration, this will handle it for you, and you're not running triggers, you're only going once to SQL, so it's going to be much more efficient, and it's going to help both you and us, because you want to get upgraded, we want you to get upgraded, so please.
Yeah, remember we upgrade you every month, so it's not like in the past, but you had to struggle with these things. We do it all the time. And it's fast normally.
Yeah, and then a specific tip for pages, both UI pages but also API pages, is to limit the use of OnFind record on next record. I'm not saying you shouldn't use it, because they definitely have their use cases. For example, matrix pages, you cannot do that without these triggers. But if you have a page where it's actually bound to a single record, there's nothing complex going on, it's just convenient to use these two. Consider if you can do it in a different way, because we have to, we like to do optimization, see, could we skip this query, could we do this differently? But if you call out to AL and do something, and you do something, you take control, you decide how to fill up the record, then we cannot assume anything anymore. So then we have to be very defensive in what optimizations we apply. So if you don't need these, then try to do without them. But of course, if you have a scenario where you can't do without them, use them. But it's just something to be aware of. They have a cost.
Yes. Bardur mentioned before that the visibility of a page is actually super important for you. So when you make a design for a page, in the top of the page, put the important information, the things that you can show them fast, because we delay load the structures. So the things you don't see on the screen right now, they're not there. If you have a fact box on a screen, if you close them by default, so people have to open them, you don't pay for the performance, and you have your first time to impression for the user getting access to the screens. So really consider what is visible by default, and what do you have to trigger to get visible. If there's something really heavy, put them below the page and not on the top of the page, because then they will be loading it, and then at least they'll have like a responsive UI, so it looks like you're not waiting. So everything is delay rendered. It's similar to if you go to a long list page. We load the first fast 50, and then we scroll, then you get some gray in the middle, and then we load the next data. So this is running all the time. The browser is a JavaScript client, so it is working like it's not just HTML you see on the screen. It's actually all the time pumping data, showing the things on the screen, asking for them, explicitly when you want to see them. So what you can do is, if fields are not visible, source expressions are not executed. So if you change your behavior from using an after-get record, which you did in the past, where you put your pre-calculated values for some kind of fields, you did that in the code. Instead, you can, it's easier to see on the screen up for you guys. If you add a function directly at the source expression level, and the visibility is false, that means that your functions will not be called. Here we have like the running balance, a pretty heavy calculation. So if you can avoid having that one on the screen and calculate if you don't need it, add your functions directly to the source expressions, then they will not get evaluated instead of using an after-get record, which is called no matter what, because that happens as soon as your record has been executed. Yeah. All right, and heavy stuff, as I told you before in the UI, if you have heavy stuff, put them to the background task. Background task, you get a responsive UI by getting the serial execution and the first get data. Then you have your screen up and running. But as soon as you need something behind the scenes, let's say you want like a web service call, or you want some heavy calculation behind the scenes, do them in the background task. The UI will come afterwards and update on the screen as soon as the data is there, and the user will have access to the screen and can start doing the typing while data pops in.
Yes, and then I mentioned before the bulk operations. So we have ModifyAll and delete all in BC, but the problem with those is often that they are only bulk. They only look bulk on the surface, but the moment you add and run a trigger or global trigger, or define a database trigger, subscribe to on before after events, add security filters, add media sets to the field or to the record, then we can no longer make these bulk operations. So the code is still going to look like it's a bulk operation, but behind the scenes we go and say, oh, but you subscribe to these things, or you want to run the triggers, tough luck. We'll need to go row by row. So if you have a table where it's important that you can insert a lot of, or you can modify a lot of data quickly or delete a lot of data quickly, then avoid adding these triggers or avoid defining these subscribers, because your code will still compile, it will still look like it's a bulk operation, but behind the scene it is no longer a bulk operation. So it's important to keep in mind these rules. Of course, this list used to be longer. There used to be more things that would block bulk operations. So we try to see, can we be smart and say still allow them? But for example, triggers, we will never have a way to do bulk operations and still run your trigger for every single row. Simply not possible. We need to read the data to run the trigger. So that's just something to keep in mind. If you want to be sure you call your bulk, can use your bulk functions, then don't do these events and triggers.
Small promotion for telemetry also here, because one day it might work for you. You're running fast, and tomorrow it's not running fast anymore. That most probably is some other extension is subscribing to one of the events, and that will also do great. So it's not always you, it's the companion of all objects together that actually does that. So you can go to telemetry, analyze if you have these kind of situation, and actually realize that someone else actually ran code on top of something you thought would be fast also.
Yeah, and then on OpenCompany should be kept fast. It's of course, if you sign into the web client first thing in the morning and then stay signed in for the day, you probably don't feel it too much. But what you don't see is that every single child session needs to open the company. Every single background job needs to open the company. Every single API request needs to open the company. And we have some customers that say, but the API request needs to be X 100 milliseconds, but that doesn't help if our OpenCompany takes 2 seconds because you need to query some external endpoint or some other thing to verify if they have access or whatever it is you put into OpenCompany. So it's important to keep this one fast and also do stuff that has a known performance. Like if you're calling a web service endpoint that is sometimes fast, sometimes slow, that will hurt your OpenCompany if you put it in there. So try to put it somewhere else or in a background job, not as part of the OpenCompany, because you are paying every single time you need to log in, both from interactive session and background sessions. You can, if you have something that is important to run, but actually only when it's a user that uses the product directly, then check the client type in on OpenCompany and do the expensive stuff only when it's actually needed. Then you can keep all your API requests fast still, for example.
Yeah, a good classic one that has been a long hassle for a long time, especially in the managed world with both Java, C# and so on, is string concatenation. if you concatenate strings, you have a lot of allocations. And if you just take one string plus another string, then you have the two strings, and now you add them together, now you have a third string. If you plus some other string to that one, now you throw away the old one, and now you make a new allocation and get a big one. So we added the text builders, which is the same as the string builder in C# to the language, because here you can now append to the strings instead. It's buffer-based, meaning that you get an amount of capacity when you start, and when you cross the buffer size, then we double it and give you more size at the end. And it's much faster, especially performance-wise, but also memory-wise. We have some memory graphs, but I think we're too detailed for the screen here. But the whole point is that you don't allocate very often. You just append to an already allocated string, then buffer that is laid out for you. But if you start doing like big strings, and you see it's like it's growing, it'll be even more stale if you go higher up, because it's simply just wasting memory, and it's putting high burden on the garbage collectors, which for us is one of the crucial points when we monitor machines. How much pressure is there, and how many users and tenants do we want to have on a particular machine when we balance the memory usage. Friend of the other triggers, if you have users waiting, don't do synchronous HTTP calls. Synchronous HTTP calls is like unpredictable, as you said before. Sometimes an API is 50 milliseconds. It might be fine, the user's waiting, but someday the internet stops you in a gateway somewhere, or the machine is not ready to respond to you, and it takes 5 seconds or 10 seconds or something like that, and your user's waiting. So don't do synchronous HTTP client calls if you can avoid it. If you have a button saying get data from somewhere, yes, then you do it. But else, you make it in a background call, make a background session, call it on a page background task. Really consider when to cache it. Do I need to call it always? Sometimes it's easy. You think, hey, they usually answer me fast, but the value is the same in the next hour. But then maybe cache your values locally instead of calling out. It's unpredictable every time you are going out of process to acquire your data. So be mindful of triggers. Every trigger is someone waiting for you guys, and it's most often a user, unless it's a background task, of course. So avoid synchronous HTTP calls if you can. This is a request for all you guys. We introduced events many years ago, integration events. We have 22,000 events today. Looking at some of the big ones that really has a lot is Code Unit 80. 520 events is in Code Unit 80. It's cluttered all over the place with new events, people getting added. Some of them I think is because it was easy to have a code customization somewhere and then just ask for an event where it was appropriate for the code customization to get your events in. Please reuse. Try to look at the events we already do have in the system, because if people are not subscribing to the events, it's still a method invocation for us to realize, oh, there's no subscribers. Okay, we can skip it and we can continue on it. But changing the code, let me just give you an example here. This is the most heavily used event-hooked method in Code Unit 80. Check sales document. There's 8 subscribers inside 83 lines of code. So someone that needs to do a feature have to refactor on it, make something smarter. It's impossible, And most of these events are so specific that I bet you that they are made for someone that needed it, like on check sales document, on after calc should check item charge. They are so specific, Please sometimes, consider making an event and make the event good for more people than just you also. So we have many places where it will be even better to make a pattern of it. With 22,000 events incoming, we can't spend days on realizing, is it okay this one? Should we throw away the ones that is hurting things and all the other kind of things? But simply, put more effort on before asking for events. It puts too much pressure on it. Think about how you get your hooks also. We have a tendency that we always pull for things, so we just ask, on an API, is timestamp larger than X? And the pull patterns compared to the push patterns, is my sound going out? It sounds like from me that sound is going in and out.
Just stand still.
Yeah, okay. All right. But webhooks, if you need to get data out of the system, don't pull on the APIs all the time. We have way too much of these things that just end up in the cache, but they are having a full thread takeover on the machine. Just to realize there's no new data for me. Use the webhooks. There's a documentation for how to subscribe to them in the bottom of the page here. Then you get a notification on data changed, and then you can afterwards call into the system and do your changes. So pile up your work. Get a notification when you need a reaction, and then afterwards call whatever you need, because now you are in reaction-based mode rather than just all the time just saying get data, get data, get data. Last line.
Yeah, last slide, but not least. Select latest version. There's actually also a new change recent. Previously, this one, the way it works is that it says to the data cache in the NST is that don't give me anything that is cached earlier than this specific, that the current time. And this was for all tables. So this means that if you put this in your code, then everything you read from the cache before, we just say, oh, disregard it. So it means that you have to start reading data all over again, which is probably what you want for a specific table. But like, how often do you want to say, I don't care about the cache for every table inside the product? Not very likely. So now, if you have this in your code, go to the code and see, okay, what table is it actually that you want to have a fresh copy of, and put the table number of that table in. An example of this is that we actually had put this into the login process without a table number, meaning every time you signed in, you said, everything that is in the cache from before I signed in, don't need it. So it's quite important to, when you use this function, ensure that you put the right table ID in there and make sure you only clear the cache for that one. We should probably do a compiler warning for that one if you still use the old one. Note to self. Yeah. Yes.
All right.
We have
questions.
55 seconds for questions.
I was told something new today, that you should not use procedures if you had smaller amount of lines in that procedure. You said there was an overhead.
Yeah, there is an overhead.
For telemetry or what?
We have to, like you saw, I think we mentioned before that we have the, like, if this, if function takes more than X seconds, emit telemetry. That means we're not emitting telemetry every time, but we have to pay for start monitoring. Yep. And then at the end we say, oh, did it go above the limit? So you have to consider that we have to do that measurement for every function. So that's a trade-off with provide good telemetry versus fast execution of functions. So that's what we mean with this.
Yeah, but the problem on the other side is that you have a duplicate code.
Yes, and it's a trade-off. We know.
Yeah. Okay.
But if you have a one-liner that just does some single thing, and you only use it in one place.
But how much is the overhead, do you think?
If your neighboring method is a database operation, then don't care. Yeah. Okay. It's where if you do like mathematical arithmetic stuff, where you're going to do heavy calculations that requires your CPU, that's where it benefit. If your neighboring function is, an insert and update, don't care.
Okay.
Can I take it?
Yep.
I have two questions. One of them is about reading on-commit data. How we can trust it, because there is no guarantee that the first transaction will successfully finish. So if you have two transactions and read the on-commit data on the second one, and the first transaction failed and roll back, what would happen for the second transaction, because you already read a data which is not valid?
Yeah, that's bad luck. I mean, that's,
that's
how it is.
What is the reason of using the read on commit? Because there is no guarantee for the first one, which will be finished successfully.
But that is true. But we also, absolutely. But we also don't want locks, right?
Yeah, but I mean.
And if this transaction does go through, then that is the new correct value. I mean, we have this discussion in item availability, for instance, right? People are posting, and so do we have 7? Do we have 8 bicycles on stock? So if another process is in the process of selling, right? It has subtracted 1, and I'm also, which is the most likely number once I finish? I mean, either could be good.
It's also like
I totally get it.
You can also design it so that you start by reading uncommitted. Then you, like as Bardur said, delay the locking, right? Then you go all the way to the end, and then you say, now I need to read the committed version. And if everything is well, nothing changed in the meantime, then I can go ahead and commit. Otherwise, I'll have to fail. Or I have to reread it again, or some other way. So you can use it to do this kind of optimistic situation where you start by reading uncommitted, then you do as much as possible before you do read the committed values in the end instead. So you can use it to get kind of full control. We also use it for cases with the job queue where you need to, you want to know the state of the job queue, but the job queue updates the records for itself, right? So you need to, you want to be able to read the status of something that is in progress. So that's you don't care if it's being changed right now. You just need to know what is the current status without locking, and that's very useful.
We do that sometimes where we first read it with uncommitted, just to see is it there, and then if we need to do something, then we lock it and read it again.
And 90% of your cases, the viewers doesn't notice if it's actually, because most often the transactions is committed. It's more seldom that you do not commit your transaction in the end. So most often it's just an observer browsing by from a list to a card, and then things on the card would appear. But you'd rather have a responsive UI than them being locked out also. So it's up for you, it's trade-off, it's optimistic concurrency.
Sure. And the second question is about SetLoad. If you just load some field and then do modification, is it going to update field by field? What would happen for the field that you didn't put inside the SetLoad? You put customer with SetLoad name, and then you modify name. But is it going to only modify the name, or will overwrite name to with blank?
No, it will only update the name.
Okay, thank you.
And the last modified by user and time and all that. So
sure.
You'll see that we always load these extra 4 fields we have at the end.
Sure. System fields. Yeah.
SetLoadField will also expand. So if you actually only ask for 5 fields, but you incidentally use them by giving it to another function and you didn't expect it, then we will just expand the cursor and not do another SQL round trip and discard the SetLoadField for that round trip.
Actually, I have a question regarding the deadlock, and now the system is actually retrying. So if you have deadlock, then they will actually retry one of the sessions, and one of the session will get completed. So the first question is, if there is a deadlock, the screen will be freeze for the user, and how the UI will respond in the case of deadlock, because afterwards the system will retry those transactions. And what will be the sequence of the transaction? Both the transaction which created the deadlock will be retried, or only one of the transaction will be retried and another transaction will be failed?
Yeah, so I'm an app developer like you, but I know that this server has something called, I think it's called transaction scope, and some of them are retryable and some are not. So if they deem that it's retryable, then they try again if it fails for instance, a deadlock. That's the overall.
Yeah, so you have to be a transaction starter. There's different conditions that will make sure that it's solid to do it. So I think if you already have a staled, then you're ending up in a real deadlock, and it has to be restarting points, and we decide in the code when the restarting points are.
Yeah. Deadlocks usually happen immediately, right? The SQL Server detects a deadlock immediately. So often it will happen quickly, and then it retries, and then if you get into the normal lock, as you saw in the example, and then the user will get a lock timeout after 30 seconds.
I think we are over time, but maybe we should...
We have been over time for a while, but we will...
we're in the experts corner, so...
We are in the bar.
Ask us.
Oh, sorry. Thank you for attending.
Thanks.